Welcome guys to Tutoring with Abdul. In today's topic we'll be talking about decimal numbers. This lecture will be divided in two parts. Part 1 will be decimal number, and we will define these decimal numbers and decimals, and we'll talk about comparison of decimals. Comparison. Pardon my spelling. And then we will see like addition of decimals, and subtraction of decimals. We'll talk about these three things in part 1 of this lecture. Stick around to learn about these decimal numbers. Our main topic is decimal numbers. In this lecture we'll be dealing with what decimal numbers are, and the operation of decimals, and comparing decimal numbers, and then at the end we will have how to convert back and forth from fractions to decimal and from decimal to fractions. So stick around this video if you want to learn about decimal numbers. And let's start up. Decimal number system, the number system that has a base of 10, such as 11, 12, 13, 120, and all the way to any number that you can think of. At 150,183, they have a base 10. So that's the decimal numbers. And the decimals are the number which consists of two parts. The one part is the whole number, and the other part is the decimal part separated by the dot. So there should be a difference between decimal number system, which is they're using a base 10, or sometime it's called like a decimal system, which is DC mean 10. So the decimal are, if you are referring to decimal, there will be a whole number, and a decimal part separated by a dot. So that's how we call it a decimals, numbers with a decimal values. So example of decimal values will be 3.75 or 3.75. It will be 3 is a whole part, and 0.75 is a 3/4, or 3/4 is a fraction, if you can write it down, or 375 out of hundreds, you can say that. 0.78 is a 0.78. So we have two parts here, like this one, and that's a decimal number right here. 8.93, and we still have the same two parts here, a fixed or whole number here, and a decimal number on this side, and so on. If you go, all these 6 example I wrote down, 6 or 7. So we know that what decimals are, and there have to be some way to compare these decimals. So how we compare these things, or the decimal numbers? There are two ways to do it. If we have a whole numbers to compare to decimals, we look at the value of the whole numbers and see which number is larger. Example 3.75 and 6.8. So if that decimal consists of a whole number, then we compare the whole number and see which whole number is bigger. So whatever number is larger, that will be a larger value. So in this case 3.75 and versus 6.8. So we know 6 is bigger than 3, so that will be automatically larger number than 3.75. And in other case, we have case number 2. If we have just the decimals, or we don't have any whole number, or let's say like if we don't have a natural number, or the counting numbers including, it should be like a whole number. We say like 0 is a whole number actually. If you don't have a counting number, if you have just this decimal to compare it, then in that case Okay, so the second scenario or case will be here. If you have just the decimal number or decimals, then the decimals which has the larger value is the larger decimal. So for instance, we said like we don't have a whole number, but if we have just the decimals, we will see whatever number has the larger value is the larger, whatever has a larger value is the larger decimals. Makes sense right there. If we say like, okay, so which one is which one is bigger, 0.08 or 0.8? If we see after this dot, whatever value is bigger, we will say that is a bigger number. So 0.08 versus 0.8. 0.8 is larger than 0.08, so we said this is a larger number than that. So I have to see 0.08. If you write it down as a fraction, so it will be 8 over 100. 8 pieces taken from 100, and 0.8 is 8 over 10. 8 pieces taken from 10. So this will be a larger number compared to that. So that's how we compare it. And this is a comparison sign. This is a larger, this means it's a smaller, and this is equal, this is equal. So we have these expression or these signs that we use it for comparing the values. So compare the following decimals. So let's say 3.08 and 0.893. So there will be 3.08 and 0.893. So we said in the first case that if you have a decimal, if you have a whole number, if the whole number is bigger than the other, like if you're comparing two numbers, if one of the whole number is bigger than other, so that bigger or larger whole number is a larger decimal number. So in this case, if we see 3 here, we have 0 right here. So 3 is bigger than 0, or 3 is a larger number than 0. So we said 3.08 is larger than 0.893. So case B or example B will be 0.06 and 0.3. So to compare this thing, we'll come to the scenario number 2. If we don't have a whole number but we got decimal, we got 0.06, 0.3. Whichever number is bigger, we're not talking about the size of the number, we're talking about the value of a number. 0.3 is bigger number than 0.06. So if you're not sure, let's see something here. 0.06, we can write that down as a 6 over 100, and 0.3 we can write it down as a 3 over 10. If we multiply both up and down of this fraction, numerator and denominator, by 10, we'll get 30 over 100. Since we can compare it, now we got the same denominators. Whichever has a larger numerator is the larger number, so this will become automatically larger. 3 over 10 or 30 over 100, they're the same. This is equivalent to 3 over 10. So 3 over 10 is bigger than 6 over 100, so which will tell me 0.3 is larger number than 0.06. Moving on to the next examples. C will be 0.118 and 0.003. To compare these things, I said like whatever value is a larger value. So 0.118 looks a larger value than 0.03, so we will automatically say 0.118 is larger than 0.003. Or if you're happy with this way, this notation, 0.03 is smaller number than 0.118. Whatever works best for us, just do that, please. Now number D will be 0.83989 and 0.83. To solve this one, it's kind of tricky because these two digits are the same. If a decimal number after the last number doesn't have anything, you can add a million zero here, but it doesn't matter anything because zero out of the after the last number of a decimal, which is this 3, doesn't mean anything. This zero doesn't mean nothing in here, so we can add as much zero as you want to, just to make it look good for that purpose. To compare these two, we have a no whole number. We have a whole number. 0 is a whole number, but we don't have a counting number, which is natural number. But we have just the decimal part. To compare that, we have to look what number is larger in the decimal part. 0.83989. If you look at this number is slightly bigger than this, because if somebody says to round it off to 1,000 or 1,000 or 10,000, this number will become 0.84. So, and this one is 0.83, and so looking carefully in here, we will say 0.83989 is larger than 0.83. If they say like, okay, just find the two significant digit there, so there'll be, you'll just have to find two significant digit, will be these two. So you'll round this one up and see like, okay, it will be 0.84. But since it did not ask that, we will leave it as it is. So that will be our comparison. Okay, moving on to the next example. Say like, write $4.30 in decimals. So how we do that? So we know what a cent is. A cent, 1 cent, $1 is equal to 100 cents. And this is S like $4.30. So it will be $4.30. We can do it like that. So that'll be this will be the answer, 4.30. I said writing down 0 after the last digit of decimal doesn't count, so you can write this one down as the 4.3. We write down 30 just to say, okay, it is 30 cents. 300 cents, 0.300 doesn't mean anything. It's still 0.3. So okay, so how we got this one here? So we have $4 plus 30 cent is we said 30 cents. A cent is 1 out of 100 is a cent. So 30 over, so it will be 30 cents. So it will be 30 over 100. So this zero will cancel out. It will be $4 plus 3 over 10. So 3 over 10, if you do the math, 3 over 10 will be 0.333. 0.3. So it'll be $4.03 or 30 cents, like that. Okay, so let's see if we have one more example here. Let's say if I have a $5.85. How we do it? $5.85. $5.85. How will you write it down? Solution will be clear. So we write down 5 as a whole number right here, plus how many cents? 1 cent. 1 cent, we can write it down 1 over 100. So 85 will be what? 85 cents will be 85 over 100. So it'll be 5.85 divided by 100 is 80.85. So it'll be 5.85 cents. So So that is our value, decimal value, value. Okay, so this was example, and this is how we find these decimals out of by saying like, okay, find $4.35. How you write it down? We write it down like 4.35. But why is it useful actually? In science, measure, and even in medical engineering, we use a prefix, which is like for example, kilometers, kilogram, a mile, centimeters, for example, as milligram. These are all base 10 right now, except that it's all this is the we are using the 10 base here. But if we want to find one out of another, so we will have to convert somehow in a decimal values here. So let's clear this out. We often deal with the whole numbers, which is relatively easy to compare, but when dealing with in some measurement which requires decimal points, is a little tricky, which is correct, which I just said. If we want to measure length, we have two systems actually. We have actually three systems. MKS, which is and CGS and FPS. It's a meter, kilo and second, centimeter, gram and second, foot pounds, second system. So we have these values. Each one have a big categories there. So 1 meter is 100 centimeters, 1 meter is 1000 millimeters, and 1 kilometer is 1000 meters. So if we have to find from kilometer, a meter will be 1000 meter, 1 kilometer in a millimeter will be let's say 10, 1, 2, 3, and 3 more zeros. It will be 1 million millimeter. And this is how we should know the decimal system. For example, here, how much is 1 centimeter in terms of meter? Okay, so we know 1 meter is 100 centimeters, but what is 1 centimeters in terms of meter? We say like, okay, 1 over 100 meter is 1 centimeter, so it'll be 0.01 meter is equal to 1 centimeters. Or say like, okay, 1 hour, 1 hour is 60 minutes and 1 minute is 60 seconds. And 1 hour is 3,600 seconds. But if you want to find 1 second in terms of hours, how we do that? So there'll be a lot of examples coming your way. So be ready for it and try to practice. Example. Find 1 centimeter in kilometer and write it as a decimal. Okay, so I said like we know that 1 kilometer is 1 meter and 1 meter is 100 centimeters. So 1 kilometer here, 1 kilometer is 1, 2, 3, 4, 5. What are we? We said like a decimal. Centimeters actually. So we said 1 kilometer will be 100,000 centimeters. To find this one, we can 1 kilometer is 100,000 centimeters. Then say like, okay, 1 over 100,000 kilometer is equal to 1 centimeter. And that answer will be 1 divided by 100,000 will give me 0.00001 kilometer is equal to 1 centimeter. Or we can say 1 centimeter is equal to 1 over 100 meter. Then meter is equal to, in terms of kilometer, there will be 1 over 100, and 1 meter will be 1 over 1000 kilometer. So if you multiply these two together, it will give me 1 over 100,000 kilometer, which will give me 0.0001 kilometer. If we know the scientific notation, so it'll be can write it down 1.0 times 10 to the negative how many number we want to move it to the right will be 5 kilometer. 1.0 times 10 to the negative 5 kilometer. We don't want to say that yet because we have not discussed the power or the exponential number exponent, so we will just brush up this right now, and this is the scientific notation. We will come to this maybe in a couple lectures of a math tutorial, so stick around this decimal point for now. And yes, there's an easy way to write it down too, which we'll be calling scientific notation. Okay, so now we talk about measuring weights. We had a MKS, we have a kilogram, kilogram, meter. We already talked about meter, but in measuring weight will be kilogram, the CGS will be gram, and FPS will be pound. 1 kilogram is 1000 gram, 1 pound is 16 ounces, 1 kilogram is 2.20462 pounds, 1 gram is 1000 milligram, and 1 kilogram is 1 million milligram. So these are the value, and this is the example that we use decimal numbers, because 1 kilogram right away is equal to 2.20462 pounds. Let's do some examples here. What is 3 grams in a kilogram? We said 1 kilogram is 1000 gram, so 1 over 1000 kilogram is equal to 1 gram. So there will be 3 over 1000 kilogram will be equal to 3 gram. So that will give me, oh, that's not right. So it will be giving me 0.03 kilogram is equal to 3 gram. That's how we solve it. Okay, so it is asked to find 320 ounce in pounds and kilograms. If you go ahead and see, 1 pound is equal to 16 ounce and 1 kilogram is equal to 2.0462 pounds. So what we can do is 1 over 16 pound is equal to 1 ounce, and we can follow up this way. So it'll be 320 ounce divided by 16 pound. If you divide that, that will give me 20 pounds. How we got that there? It's actually right here. 320 ounce time 1 pound is equal to 16 ounces. So it'll be 1 pound over 16 ounce. Ounce will cancel out with ounce, and 320 divided by 16 will give me 20 pounds. So that's how we got that 20 pounds out of there. Now let's find it in the terms of MKS, or since we don't have a meter, so just find it in a kilogram. We already said 1 kilogram is equal to 2.0462 pounds. So we can do it we can solve this example in 2 ways. We can either go by ounces, 320 ounce we have, or we can use that's equivalent, which is 20 pound. Either way we should get the same answer. Let's try to do both way, see what happens. So 320 ounce let's do pound first because it's relatively easy and not very confusing. So if we have 20 pounds, if we want to find that in a kilogram, will be time 1 kilogram is equal to 2.20462 pounds. Pounds will cancel out with pounds, and we can divide 20 divided by 2.20462 will give me 9 0.0718519 kilogram. So 20 pounds will become 9.0785819 kilograms. So to find it other way around, we will have to use two different fractions. So two fractions will be 320 ounce. 320 ounce will be 1 ounce is equal to 1 pound over 16. 1 pound is equal to 16 ounce. And then how we find out 1 pound in terms of kilogram. So the second fraction will be here. 1 pound is equal to 0.45 kilogram, will be 0.45 kilogram over 1 pound. Pound will cancel out with pound, ounce will cancel out with ounce, and then we can do the multiplication here. See what number we get. 320 divided by 16 times 0.45. We get 9 even kilogram, because I use 0.45 kilogram instead of all decimal number. So these are relatively close to each other. The difference is because I did not use the fractions. After 0.45 kilogram, I used the whole exact decimal number. So that's how we find it. So you can use both direction. You can go from pounds directly to kilogram, or you can go from ounce to pounds, then goes to kilogram too. It requires a little bit more practice. Please practice, keep practicing. It'll get to your brain sometime. Like it takes time. Okay, right, 35 cents decimals. 35 cents in decimals. We know 35 cents are like 35 over 100. So if you divide 35 over 100, will be 0.35. Will be our answers. 1 cent is equal to 1 over 100. So 3 cent will be equal to 3 over 100. Same thing, 35 cent will be equal to 35 over 100. So that's how you find it. There will be 0.03. There will be 0.01. Will be 0.35. So that's how we find these decimals. Okay, moving on, changing gears to how to add decimals and addition of the decimal number. In addition, we add whole numbers to whole numbers and decimals to decimal numbers. Simple as that. Just add each number to the each individual parts of it. Example. A zero. As we said, like a zero to the after the last decimal number doesn't change the number. For example, 3.5. This is the last decimal here. After that, you add many zero here. It doesn't mean anything. Same thing here. Doesn't mean nothing here. So let's find these example and solve it. Let's solve like A and B. 2345.600 and add that to 801.8031 and all these B and C. If you have to do it so horizontal way, so you have to match. This dot should be under the dot. Dot should match the dot. Dot should be underlying the dot, or this has to be in a vertical position. So 2, 3, 4. Write down the bigger number first, if you could. It'll be 2345.6000. We only had 1 0, but once you write down plus 801, this, and the second part is 6.6031, that one. Since you only have two zeros here, you can add one more zero, because if we say that adding zero to the last part doesn't change anything, it will be just for decoration or our solving purposes. So if you added one, then how you add it? Just add one by one, a number to the number. 1 and 0 is 1, 0 and 3 is 3, 0 and 0 is 0, 6 and 6 is 12, 12 and 1 will go up right here. So 1 and 5 is 6, 6 and 1 is 7. Bring down the dot. 4 and 0 is 4, 3 and 8 is 11. 1 will go here, and 1 and 2 will be 3. It will be 2,000. Oh, sorry, that will be 3. 3,147.2031. Okay, let's do B, and I'll leave C to you guys. I said here, write down the bigger whole number first. Be 3,001.30016 plus, what is the number? 161. I said dot should match with the dot, so it will be 1. Oh no, sorry, not this one. It will be 12. 1, 2. This number, a whole number, should line up. Ones will be under the ones, tens will be under the tens. So then you have dot, or the decimal will be 2, 5, 1, 4, 5, 0 and 0. If you add them, 0 doesn't mean anything after that thing, so we can just leave it off, or even just can erase it here, just to not confuse you guys, because we don't need it for decoration here too. And I said we can add numbers to the number vertical way. So 6 and 5 is 11. 1 will go right here. 1 and 1 is 2. 2 and 4 will be 6. 0 and 1 is 1. That will be 5. 2 and 3 is 5. Bring down the dot back down. 1 and 2 is 3. 1 and 0 is 0. 0 has nothing to add to, and 3 doesn't. Be 3013.55161. Why you guys don't do C and see what you guys get? Please let me know. You do this. You do this. I know you can do it. Alright, moving on to subtraction of the decimals. Same as simple whole number subtraction, but here we deal with decimals. Yes, correctly, we deal with decimal numbers, so we have to keep in mind something. We have minuend and subtrahend. It's same as whole numbers subtraction. In this example and the decimal part, up to this point of math, we always take the smaller number from the bigger number. Of course, we can take in a higher up math classes, we can do some example like, okay, we're subtracting a bigger number from a smaller number. That will be a different case, but in this class or this part of math, we can only do a bigger number should be always in the top, or that should be minuend, and the subtract will be a smaller number. So let's do some following example. I said 4,000.80818 minus 61. So this number should be always bigger than that in this section of the math right now. Later on we can discuss otherwise. 40 minus 16.38, 14.389, 3898 minus 9.0081, and keep go on. So far we are doing okay. Let's do A. Oops, that's not right. That's not the way I want that. Let's do example A. A is 4,000.818 minus, what is 61? Ones should be lining up with ones. Tens will be tens. I'm writing down bigger so we can all see it. 61.8, and the dot should line up with the dot. 839. Alrighty, that looks beautiful. That looks beautiful, but this one doesn't look beautiful. Let's correct these. So that was 1 8. So 8 minus 9, we cannot do that, but we will have to borrow 1 from here. It will be 18 minus 9 will be 9. So we had since we borrowed 1 here, that become 11, and that was 11 because we borrowed 1 from here. So this will become 7 right now, and this will become 11, but we took it out of here. It will be 10 minus 3 will give me 7. Since we have only 7, we can borrow 1 from here. It will be 17 minus 8 will give me what? 9. Alright, dot will go there back. So this 0, we cannot minus 1 from there, but we already borrow 1 from here. This becomes 10. 10 minus 1 will, we gave it to here, and now this will become 9 because we borrowed 1. Well, we lended 1 to this. It will be 9 minus 1 will be 8. Same thing we did here. This was 10, we borrowed right here, we lended to this guy, and that will become this became what? This become 9. 9 minus 6 is 3. Same thing here, we had 9, and that will be 3 because this is the main boy, this is the big boss here because it just lended to all of them. So this one lend 1 to here, it will become 9, it will become 10. This lended to this one, that become 9, that become 10, and that lended to this guy, this become 9, this become 10, and same thing so on. So 3,938.979 was the answer. Let's do number D as I said. Okay, so 101.1018 minus 35.1. And earlier we said we can add as many zeros as we want to make it look good. Okay, because these 0 doesn't mean nothing after the last decimal parts of a decimal number system. 8 minus 0 is 8. 1 minus 0 is 1. 0 minus 0 is 0. And 1 minus 1 is 0. 1 minus 5, we bring the decimal down. 1 minus 5, that's not possible, but we have to do some borrowing here. We borrow from here, then this borrow from here. So that'll become 10. This will land right here. This will become 11. 11 minus 5 will 6. And since this was 10 before, now it blended this one to 1 right to this one, it will become 9. 9 minus 3 will be 6. So there was 1, they already landed to this guy, so there's nothing left there. So it will be 66.0018. So you guys do B and C, and let me know if you guys have any question. We will come back to the part 2 of this video, part 2 of this lecture, which will be multiplication and division of the decimals, and finally we will have some other topic like how to find a percentage of certain numbers. We will discuss those things in part 2 of this lecture video. So please go and practice the one that we studied, addition and subtraction here, and I'll see you next time. Please don't forget to subscribe.